Hello guys, this is Justin Bibilan and welcome to this episode of Don't Panic, It's Organic.
Hello guys, this is Justin Bibilan, aka Organizon118, and welcome to this episode of Don't Panic, It's Organic. Okay, so last episode we discussed about aromaticity, benzene, and naming aromatic compounds, and also some heterocyclic aromatic compounds and reactions involving benzenes. So for today's or this week lessons, we will discuss about alcohols, phenols, thiols, and ethers. So what are these organic compounds? So first, what are alcohols and phenols? Okay, when we say alcohol, the general formula is actually ROH. So there is a functional group which is actually a hydroxyl or OH. So if R is an alkyl, then it is an alcohol. But if R is an aryl, then it is a phenol. Okay, we already know what are alkyls or what is an alkyl. Okay, while an aryl is actually a benzene. Okay, so from the root word aromatic, okay, aryl. Okay, so if there is a benzene, then attached to it is a hydroxyl or OH, then it is a phenol. Okay, so we already knew what is a phenol when we discuss about naming aromatic compounds. Okay, so ROH is the general formula for alcohol. So as you can see, you have ROH for an alcohol, then you have your phenol. So this is an aryl, which is a benzene. Attached to it is an OH, then therefore that is a phenol. So example of alcohol is you have your methyl alcohol, because this is an alkyl, this is a methyl, and that is an alcohol. A functional group for alcohol is OH. Then the common name should be methyl alcohol, while the IUPAC name is what we call methanol. Okay? So we will learn more about naming alcohols later. So example of alcohol, if you have your 1 carbon alcohol, that is methanol. If you have your 2 carbon alcohol, which is actually the ethyl alcohol, or the IUPAC name is ethanol. Then you have your propanol, 3 carbon alcohol. Then you have your 4 carbon alcohol, which is a butanol. Then you have your pentanol 5, you have your hexanol 6, your heptanol is 7, 8 is your octanol, 9 you have your nonanol, and your 10 is the decanol. Okay? So what are ethers and thiols? How are these differ to each other? So the general formula for ethers is actually ROR. So ethers are two alkyl or aryl groups attached to oxygen atoms. So you have your R, 2R, which can be an alkyl or an aryl attached to your oxygen atom. Okay? So it can be both alkyl, your R can be both alkyl, your R can be both aryl, or your R can be a mixture of your alkyl or aryl. Okay, so that is an ether. Thiols contain a sulfhydryl group. So what is this sulfhydryl groups? So the general formula is RSH. So if you can find SH, then that is what we call the sulfhydryl group. Then that organic compound is a thiol. Okay? So example of an ether, so you have your methoxymethane or dimethyl ether. Okay? So the UPAC name for this is methoxymethane, while the common name is dimethyl ether because there are 2 methyl attached to it, then attached to your oxygen, then therefore this is dimethyl ether. Okay, so this is the general formula for ethers. Then you have your general formula for thiol, and the UPAC name, for example, a 1 carbon thiol, you have your methane thiol. Okay, that is methane thiol. So let's move on to the properties of alcohol. Okay, alcohol is a very unique organic compound. It's because of its hydroxyl group. Okay, so the hydroxyl group that is attached to your R group, that's what makes your alcohol a very unique organic compound. So the band angle for your alcohol, that is the band angle for our ROH, is actually 104 degrees. This is a very similar to your structure or geometry of your water, which is HOH. Okay, so the geometry for water is actually bent, which is also the same as your alcohol. So bent is the structure for alcohol and also for water. Then because of its hydroxyl group attached to your alcohol, it is actually very polar because of its OH. And you know that oxygen is electronegative or more electronegative than your hydrogen. Then the difference between their electronegativity constitute to the polarity of your hydroxyl group, and therefore the overall structure of your molecule also is a very polar substance. Okay, because all of the electrons will be pulled out by your oxygen since it is electron withdrawing because of its electronegativity. That means it has the ability to attract electrons coming from the structure, coming from your hydrogen or any atoms that is actually attached to the oxygen. Okay? Because of this hydroxyl group and this polarity and also the electronegativity of your oxygen, it actually constitutes or contributes to the intermolecular force, which is what we call the hydrogen bond. Hydrogen bond is a very strong intermolecular force that is actually affects the physical properties of your alcohol. Okay, so the hydrogen bonds can form between two alcohol molecules, or it can also form your alcohol can also form hydrogen bond with water. Okay, so what is these physical properties attributed to your alcohol because of hydrogen bonding? We have your higher boiling point compared to alkanes, alkenes, alkynes, and other organic compounds. So you would expect that alcohol has the higher boiling point than your alkanes, alkenes, and alkynes because of hydrogen bonding. So how is this hydrogen bonding exhibits? Okay, that's why also your water has a boiling point of 100 degrees Celsius. Okay, it's because your water is also capable of hydrogen bonding because of the presence of your oxygen and also the hydrogen that is attached to it. Okay, so how is this hydrogen is formed? Hydrogen bonding is formed. So let's first discuss the boiling point. As you can see, you have your alkane, or this is a butane, which has a molecular weight of 58. And you have your 1-propanol, which is actually the molecular weight is 60. So more or less, they have the same molecular weight, but you notice the differences in their boiling point. That is a very large difference. Okay, your boiling point of your 1-propanol is more likely 97.2 degrees Celsius, while your butane is negative 0.4 degrees Celsius. Okay, because your butane, the only intermolecular forces is a very weak intermolecular. It could be van der Waals, which is an hydrophobic interaction. It could be. So this is a very weak intermolecular force that could be attributed to the structure or the overall property of the butane, because all of these are it only constitute a carbon hydrogen, which is actually, this is a very nonpolar. Okay, your alkanes are nonpolar, while your alcohol is a polar molecule, and because of this OH or hydroxyl, it contributes to it actually forms hydrogen bond to each other, and it's a very strong intermolecular force. Then it needs a lot of energy to break that intermolecular force, and therefore it needs a lot of heat. Okay, so that you can break the intermolecular force between two alcohols or between alcohol and water. Okay, that's why the boiling point should be 97.2, which is a very large difference between your alkanes. And also for alkanes and other organic compounds, your alcohol has a really large or has a higher boiling point than those organic compounds. So this is what the structure of your hydrogen bonding is. So in letter A, hydrogen bonding can be formed between two alcohols. Okay, so you have your oxygen, which actually has two lone pairs. So we've discussed about already that your oxygen has two lone pairs on its structure. Okay, so your lone pairs of your oxygen, this is actually now becomes a partially positive, a partially negative oxygen because of it is more electronegative than your hydrogen. Okay, so since it is more electronegative, then it has a partially negative on its atom. Okay, while your hydrogen has also a partially positive because it is an electropositive. Your oxygen is an electronegative while your hydrogen is an electropositive. Okay, so if your oxygen, if there is a neighboring another alcohol which is also has a hydroxyl group, then this oxygen can hydrogen bond to the hydrogen of another alcohol. And also if this oxygen has a neighboring hydrogen, then it also can hydrogen bond to that hydrogen of the another alcohol molecule. Okay? Or letter B, your alcohol can also form hydrogen with the water. Because remember, your water has also oxygen, and at the same time it has two hydrogen which is capable of hydrogen bonding to another oxygen atom. Okay, just like this, if you have your alcohol, okay, so the hydrogen there can also form hydrogen bonds with the oxygen. While for water, it has two hydrogens, then therefore it can also form two hydrogen bonds with your oxygen of another alcohol molecule. Okay, so that is the concept of this hydrogen bonding. And remember, it is a very strong intermolecular force, and therefore it needs a lot of energy to break that strong intermolecular force or to break that bond. And therefore, your alcohol can attain its maximum boiling point of around 97 or above 90 degrees Celsius because of a strong intermolecular force, just like your water, which is what we call hydrogen bonding. Okay, so take note of that. That is hydrogen bonding. So alcohols can form intermolecular hydrogen bonds with water, hence they are soluble in water. So most alcohols are actually soluble in water, just like your ethyl alcohol, your methanol. Okay, so alcohols fewer than 4 or 5 are actually very soluble in water, while those alcohol that has already 5 to 8 carbons, they are now moderately soluble. And therefore, if you have 10 to above carbons of an alcohol, then that could be not soluble in water anymore. So why, as you as an alcohol become more saturated with a hydrocarbon chain, it becomes it is close to insolubility, or it's not soluble anymore in water. Why? It is because, like for example, of this octanol. Okay, so actually, if I told you that your hydroxyl here, this one is OH, that is very polar because that will form the hydrogen bonding with water. Okay, that OH there. So you can say that this OH can form hydrogen bonds to water. Then this is actually hydrophilic because this is water loving. So when you say hydrophilic, then that is water loving. From the root word hydrophile, okay, which is philo, which is actually love. Okay, so that is a hydrophile or hydrophilic. Okay, so this, if I told you that your alkanes is an hydrocarbon chain, which is actually hydrophobic. So this is hydrophobes. Okay, that means this is water fearing. Okay, so that is hydrophobe. Okay, or water fearing. So, okay, hydrophobe. Okay, so in other words, that if your alcohol becomes very saturated with the hydrophobic tail, so we can say that this is a tail of your alcohol or the tail of the OH, then the OH is the head. Okay, just like it is a worm. Okay, you have your head, which is a hydrophile, and your tail is anhydrophobe. So in other words, that if an alcohol is a very saturated with hydrocarbon chain, the overall physical attributes of that alcohol will become non-polar. Okay? Because of this very long hydrophobic hydrocarbon chain. Okay? While if it is only fewer than carbon, like for example, if it is only 2 carbon, then your hydrophile is more likely a very has a strong influence to the overall structure. Okay? But if then alcohol has a very large or has a very has a very long hydrocarbon chain, which is actually a hydrophobic hydrocarbon chain, then the overall structure, the overall property of that alcohol would be attributed to its hydrophobic in nature. Okay, so that means it is non-polar. Okay, that's why if you have a large hydrocarbon chain or like 10 carbons already on the alcohol, then it is already insoluble in water because the nature of that alcohol is now hydrophobic or is now non-polar because of the longer hydrocarbon chain. Okay, so that's it. Okay, so now let's move on to the naming of alcohol. So how do we name alcohols? Okay, first, you determine the name of the parent compound. Okay, that's the same as what we have discussed on how do we name organic substances according to the IUPAC nomenclature system. Okay, so determine the name of the parent compound, which is the longest continuous carbon chain containing the OH group. So remember now, the OH is now our priority. Okay, because that is an alcohol. Replace the E ending of the alkane chain with the OL ending of an alcohol. Okay, so if it is ethane, then the E ending of that ethane, you replace that with an OL. So that becomes an ethanol. Okay, so an alkane becomes an alkanol. Okay, like methane becomes a methanol, propane becomes a propanol, butane becomes a butanol, pentane becomes a pentanol, and so on and so forth. Okay? Number the parent chain to give the lowest possible number for carbon bearing the OH group. So remember, your OH or the hydroxyl group is our priority. So you should number the longest continuous carbon chain in such a way that your carbon bearing the OH would attain the lowest possible number. Name and number all substituents and add them as prefixes to the alkanol name. Okay? Then alcohols containing 2 hydroxyl groups are named diol. So if there are 2 OH attached to that parent compound, okay, then you can name this as a diol. Okay, like for example, if it is a propane with 2 OH, then it could be propane diol, okay, or ethane diol, or butane diol, okay. Those bearing with 3 OH groups can also be called a triol. Okay, like a propane containing 3 OH, then that could be propanitriol or propane triol. Okay, a number giving the position of each of the OH group is needed in these cases. So you should number where is the OH attached to what carbon number. Okay. So for example, so what would be the name of this organic compound or of this alcohol? Okay, remember rule number 1, you number your longest continuous carbon chain and also that your OH becomes your priority. So therefore, OH should attain its lowest possible number. Okay. So we can number this as 1, 2, so that your OH will attain its lowest number. Am I right? Okay, you have your 3, then this would be 4, and that would be 5, and this would be 6, and you can also make this as your 7. So therefore, your parent compound is a heptane. But remember, this is an alcohol. You drop the E. Okay, you drop the E for heptane, then you replace it with OL, so that becomes a heptanol. So this becomes a heptanol. Okay, so the parent compound will now be a heptanol. Now, what is this heptanol? This is actually 2-heptanol. Okay, that is correct. That is 2-heptanol because your carbon number 2 contains the OH. While your substituent, what is your substituent? That is a methyl. So where did you find the methyl? That is actually on carbon number 6. So the name would now be, okay, wait. The name would now be 6-methyl 2-heptanol. That is correct. 6-methyl 2-heptanol. Very good. Okay, next. How about this cyclic alcohol? Okay. Remember that your OH is your priority, then this could be carbon number 1. Okay. Then we can say that this is carbon number 2, so that your carbon number 3, which is a Br, would attain its lowest number also. You cannot number this as 1, 2, and 3, and 4, 5 because that is already number 5 for Br. But you can number this as 1, 2, 3, 4, 5, and 6. Okay. Remember, this is a cyclic, so this should be cyclohexane. But remember, this is an there is an OH attached to it. Then you drop the E for cyclohexane, the ending E, and you add OL. So this becomes cyclohexanol. Correct, cyclohexanol. Cyclohexanol. Okay. And remember, in this cyclic compounds, you cannot anymore put the number as 1 cyclohexanol because it is understandable that this is actually on number 1. Because whenever you put OH here, that also becomes number 1. If this is OH there, then that becomes also number 1. So wherever you put the OH, that becomes number 1. However, if there are 2 OH, then you should number that already. But there's only 1 OH, and that is our priority. So wherever your OH is there, okay, whatever position it has, that should be considered as number 1. So that is understandable. So you will not say that is 1 cyclohexanol. Okay, you just proceed to the substituents already. That becomes 3-bromo. Okay, 3-bromo cyclohexanol. Very good. So this will now be 3-bromo cyclohexanol, not 3-bromo 1-cyclohexanol, because this is understandable that your OH should be on carbon number 1. Okay? So the answer would be 3-bromo cyclohexanol. Correct. Okay, next. So this is an example of a diol. Okay, so when you say diol, it contains a 2OH. Okay? So we should number this. Okay? The longest continuous carbon chain. So that would be the longest continuous carbon chain. And how many carbon? There are 4 carbons. So this is a butane. But you drop the A. But this is a diol. So you cannot anymore drop the A. Okay? Because this is a diol. So the name would now be butane diol. Okay, you just name it as butane. Butane. Because this is a diol. Okay, butane diol. So you name it as an is, butane, then you just put the word diol. Okay, so in what position that your diol is there? You have your 2,3 butane diol. Very good. That is 2,3 butane diol. That is now the name of this compound. In carbon number 2, there is an OH. And in carbon number 3, this is also an OH. Then therefore, that is 2,3 butane diol. Very good. Next. So now you have your 3 OH attached to it. So therefore, this is a triol because of 3 alcohol or 3 OH. So again, your number 8 was 1, 2, 3. Longest continuous carbon chain. Okay, that is propane. So you should expect that is propane triol. Okay? So propane triol or propanitriol. Okay? Propane triol. Okay? Then, what number are your hydroxyl? You have 1, 2, 3. So, this becomes 1, 2, 3 propanetriol or propane triol. So, then you're done. That is now the correct name for that alcohol. 1, 2, 3 propanetriol.